back to lesson 6. You want to go over the homework?
Yeah.
Like the quiz part or the attached part that goes under individual preparation?
Hold on, let me just... So I think I did fine on this one because I got 100 on it the second time.
I got a C-, but I didn't retry it.
Yeah, I think I got a B and then did it again. Okay, this is... Okay, I think it's just the regular standard deviation, and then the only things were like what is it, right skewed or normal.
Mm-hmm.
Yeah.
Just do the group quiz on this one then?
Yeah.
Okay.
So we can get on to the next one. Okay. You there?
Mm-hmm.
Yep.
I did the first 2.
Yeah. Okay, so we'll start on number 3. When using the when taking sample. When using the when
I
taking
think
sample.
maybe when using was like a typo.
Okay. So when taking samples of 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
I don't remember this at all.
I think... Hold on. Yeah, again, I'm like, I didn't take this one that recent.
Yeah, I'm gonna try and get the lesson open.
Okay.
Is this even in lesson 6?
Yeah, like if you pulled up the I'm trying to think if it was the homework, or I think this is the homework. They have like similar questions. So I think the first one, because yeah, if you do the homework, went over the homework, it goes. Try to pull up the quiz. It talks about how if the sample is like lower, like 4 people, then it's a right skewed. But then if like the sample is like higher, like 100, then it's a normal. It's normal.
So then how would it get skewed left? Or does it just never get skewed left?
I don't think it ever gets skewed left.
Okay, so you think 3 is skewed right?
Yes.
Okay. Okay, so number 4 is the same thing, only with a sample of 100. So in that case, would it be normal?
Yes.
Okay. All right, 5 is when using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed? What does... Wait, which applet is this?
What? I think it's
Oh,
the regular,
well, because
the
it gave us...
chapter
There was
5
another one in
applet.
this one, and it was those graphs thing. Like you click on it and it takes you to a different page.
Yeah.
Was it that one? Is that what it's talking about?
Mhm.
Okay, so it says when n equals 5, and I think it's normal. I think the answer is normal.
Mm.
Because on here, I'm looking at it, and it looks like the n, it says n equals 5. So, and it looks normal. Oh wait, or do you have to press?
I'm trying to find that. Oh, there it is. The applet. Okay. Hold up here. Okay. What's the question? Sampling. Is that what? Um. Okay. That is a different thing. Dang it. I didn't understand this chart that they gave us because it's not the one that we worked on with lesson 5 actually.
Wait, which one are you talking about?
The the question 5, the sampling distribution applet.
Uh-huh. Yeah, I'm looking at it and I don't really understand it.
Hmm. Okay, n equals 5. Now what?
I think that the answer would just be normal. Well, I don't know, because there's only 5.
I guess normal.
Yeah, we might as well.
I don't know.
Yeah, I don't really know either.
If you don't know, best guess would be normal.
Yep. Alright, so number 7 is, when will the distribution of means be normally distributed? Choose all correct responses.
Wait. Did 6? Did you just go to 7?
Oh wait, did I skip one? Oh, I skipped 6. So 6 is the same thing, except for it's 100. Would they both be normal then?
Hold on. Um, I'm kind of like, is it the same as the top ones then?
Should we say that maybe 5 is skewed right since there's only 5? Or is it different
Part of
because...
me is like, we should do skewed right for 5 and then normal again for 4. Because it looks like it's the same exact question as on top.
Okay, so 5 is skewed right?
Yeah, 5 would be skewed right and 6 would be normal. Because I don't really see the difference between 4 and 6.
Okay.
Oh, when normally distributed? I mean,
Yeah, so 3 and 4 were right skewed, 5 and 6 was normal for the parent population.
right skewed. Yeah, we'll come back to that.
Okay. So what are you thinking for 7?
7.
I know the second one is right, but I don't know about the other 3.
Data search algorithm. Um, um, so small, okay, normally distributed or right skewed. Normally, I think it would be sample size would be large on a normal distributed.
Mm-hmm.
So 2
Yeah.
and heavily skewed. I think it has to be large again. So 4.
Okay.
Cause do you have the lesson plan up?
Uh-huh.
And like the 2.1 when x normal?
Yeah, I'm looking at that.
Yeah, and the second bullet and then the fourth bullet. I think that's what it's saying, right?
Oh, yeah, you're right. You're right, it is.
Yeah, because it's like talking about much larger samples and
And then it's
um,
also saying that if the parent population is normal, then even a small sample size can lead to normal distribution. So I think it would be all of them except for the third one.
um, so moderate. But what is it saying that like the moderate size, like skewed, a sample size of 30 is traditionally thought to be sufficiently large?
What are you saying?
Like the sample size, if it's low, is that in the one, two, three,
It's
four?
the third bullet. It says if the parent population is almost normal, then a sample size of 5 will probably be sufficient to assure that X will be approximately...
Okay, okay. Yeah. I was looking at the bullet ahead. Okay. Yep. I'd go with those 3 then.
The first, second, and fourth.
Um, yes.
Okay. So 8 says, which of the following gives the best explanation of the central limit theorem? And we can kind of just look up what the central limit theorem says.
It's right above where we were looking.
Mm-hmm.
So the sample distribution of the sample mean will be approximately normal if the sample size is sufficiently large.
Yeah, and that looks like that's the fourth option on number 8.
Yeah, because I think the third one was the other one from last week.
Mm-hmm.
Wait, yeah.
Mm-hmm.
So the other one was the large numbers law. Okay, so 9. What is the mean of the distribution of samples? Oh, hold on. Let x be a random variable with population mean 10, the population standard deviation 6. Suppose the sample size n equals 36 is drawn from the population. What is the mean of the distribution from the sample mean? So, hold on, let me calculate.
How do you do this?
This is where you do wait, we're finding the mean?
The mean of the distribution of sample means.
That's just 10. Because the distribution sample mean is the same exact thing as the population mean.
The mean of the distribution of sample means is just the population mean?
Yeah.
Oh, okay. So it's just 10?
Yes.
Oh. And so then from 10, the standard deviation would just be 6?
No, that one will be different. Because
Okay.
you have to put in the formula for that one. That one would be 6 divided by the square root of 36.
6 divided by the square root of 36.
Because it'd be the standard deviation divided by the size.
So if it's 6 divided, the square root of 36 is 6, right?
Yeah, so it's 1.
6. So it's just 1?
That's what I got.
Oh, okay. So 11, regardless of the distribution of the population, if the sample size is large, what would the shape of the distribution of the sample mean? It would just be normal, right? If it's big enough, it'll just be normal.
Yeah.
Okay. And then to justify that, that would be the central limit theorem, right? Because the central limit theorem says if the sample size is large, the shape of the sampling distribution will be approximately normal. So I think it would be central limit theorem.
Yeah. Okay, so let's go back and recheck. So 3 we got skewed right.
4 we got normal.
5 we got skewed right.
6 is normal.
7 we got 1, 2, and 4.
Yeah. 8 we got the fourth one.
9 we got 10.
10 we got 1.
11 we got normal.
12 we got central limit theorem.
Okay. Let me just check the 2 ones just to confirm. Okay. Yeah, we'll just go with it.
Okay. Hey, 92%. Pretty good.
Sweet. What did we get wrong?
Oh, we only missed number 5,
Okay.
which was supposed to be skewed right. But yeah, we only missed 1. That's pretty good.
Yeah. I ain't gonna complain.
Yeah, I'm good with that.
Yep. Okay, so go to 7.
Yep.
Okay.
So yeah, so I did not understand pretty much any of this. Number 7.
Okay. Okay. Let's get.
Do you want to just work through it on the quiz?
Yeah, we can do that.
Okay. Okay, are you ready?
Not yet. Okay. Okay. Where is this? Okay. Okay. I'm ready.
Alright. So, number 3 says, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left of the same thing. That one looks pretty easy because you just put it into the applet.
Okay. So where's the app?
I think that's under lesson 5.
Z. Where the heck am I? Okay. So 1.358. And we're going.
We're doing the left and the right and unshading the middle.
Left and right and unshading the middle. Okay.
So I got 0.1745.
That's what I got.
Okay. Do you round, if it's a 5, do you round up?
Yes.
Okay. So 0.175.
Yes. Okay. So the next one. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviation of passenger weight is 26.7 pounds. The weight of the random sample of 48 commercial boats passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample. Round to the nearest blah blah blah, and then you would. Oh, okay. No, as an extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also the values as far away from the mean as ours in the positive direction.
Okay.
So,
Is this the type of thing like what we just did where we find the z-score and do everything that's to the left and the right? Is that what it's saying?
yes.
Okay.
So to find the z-score, this is where we use the different formula that we were given, which is the value minus the mean divided by the standard deviation, which the standard deviation is the standard deviation divided by the number, the value, the n.
Okay, alright, that's starting to make more sense now. Because when I was doing the homework, I couldn't figure out what the equation was, but okay.
Yeah. So for this one, we would do
so what is the square root of, we're trying to figure out the square root of 48?
yes, so it's 185 pounds minus the 177.6. Then that divided by, and then in parentheses on your calculator you do 26.7 divided by square root of 48.
My calculator is not advanced enough to do that.
So, but okay, I always just like how I put it in my calculator because I just have like a basic kind of calculator.
Yeah, I just have the one on my phone.
Let me see, hold on. Okay, so I always just do, because I don't like doing like the full equation in one time, I just do the value minus the mean and then press enter, and then do divided by, and then do in parentheses the 26.7 divided by standard, square root.
Okay. What is the square root of 48? What do you press? How do you get the square root of something? On a calculator.
I put second, and then it's in. Because mine. Let's see if I can find it on here. Let's see, where is it? So mine's like right here, but it's like in the second part, so I have to put second and then the bottom.
Oh, see, I just have like a basic calculator on my phone.
Let me see. So yours would be right here underneath the percent to your far right.
Oh, okay, I see it. All
Is
right.
that the square root, or am I saying it wrong?
I think you're right.
I don't know if I'm calling it the right thing.
Yeah, I think that's what it is. Okay. Okay.
Whoa, I got a different answer this time. I did it again. Hold on. Okay, so I got 1.920. So then we would put that in our chart.
Here, I'm gonna see if I can do it too. So wait, what's the part? What is the value? Because it was the value minus the mean, and what value are we using?
The 185.
Oh, so it's just 1.
So it'd be 185 minus 177.6.
Oh, okay. So it's the mean minus the value? Or is it the value minus the mean?
The value minus the mean.
So then it would be 177.6 minus 185?
No. It'd be the 185 pounds minus the 177.6.
Isn't the 185 the mean?
It's a mean weight of the passengers, but the sample mean is 177.6.
So we're doing the sample mean, the mean minus the sample mean?
Yeah. Hold on, hold on. I might actually have gotten that wrong. I think you might be right. If the sample mean is normally distributed when the sample mean, then we consider the sample mean. Okay, no, I'm wrong. You're right. It goes sample mean minus the regular mean.
Okay.
So 177.6 minus 185 equals then divided by, in parentheses, 26.7 divided by square root of 48, which is the same thing.
Yeah, it's just negative. So for the z-score, you got 1.92?
Yes.
Okay. All right. And then for the area, 0.0549?
549. Yeah, so we do 0.55.
Okay. Or 0.055?
Yes.
Okay.
0.055.
Okay. So number 5, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? What a smaller standard deviation.
So this is not a question that we got before.
Would it be this can't be determined? Or is there a way to know?
Trying to go in the back to the homeworks. See if they say anything. The following observations deviation of 9 observations. I mean, I guess you can't really know.
Should we just go with that?
I think because, I mean, we aren't given any other information, so if we just are given 9, there's nothing we can do about, like, with it.
Okay. So 6, which of the following results implies that the spread in X decreases as the sample size increases? And I want to say central limit theorem.
Which following results implies that decreases, increases. Um, I'd go back to this one. Last. Okay, so recap, the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean. Then the central theorem, the distribution of sample means is normal when X is normally distributed or when the sample size is large. What's our other options?
Normal distribution and the 68, 95, 99.7 rule.
The distribution of all positive sample means for a particular size, its mean. I don't think that has anything to do with it.
Yeah, and I don't think the percent rules do either. I'm pretty sure it's central limit theorem.
So, part of me, I don't know. Sample mean of X normally distributed when the sample. Yeah, we'll go central.
Okay.
Good. So scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation 8.8. Use this information through 7 to 6.
7 through 10.
Oh, yeah, sorry. 7 is Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding with Diane's score?
Okay.
So we would do. Okay, this is where we.
This would just be like a normal z-score, wouldn't it?
Yes.
Okay.
Because we aren't given the n.
So it's just 160 minus 150.8 divided by 8.8.
Hold on. I'm trying to pull it up. So 160 minus 150 divided by 8.8. So I got 1.0454.
Me too.
1.045.
Yep. Okay. Number 8. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Would we use the applet for this?
Yes.
Okay.
And we don't have to, we just use the same number we just got.
Yep.
So 1.045. And then,
it would
is
be
it
the right.
above?
Yeah, so it would just be the right one.
So 0.148.
Yeah.
Okay. So 9 is a random sample of 5 students was selected to take the GRE. The scores were 160, 175, 163, 149, 153. What does Z-score correspond to the sample means of these students' scores? Okay, so we're using the now formula, the newer one, because we have the N now.
Mm-hmm.
But
So first we find the mean of those scores. We just add them up.
okay. 160. So 800 then divided by 5.
Yeah, and that's 160.
60.
Okay, so we have that.
So we do 160 divided by, 160 minus, go up a little bit, 150.8. 8. And then divided by, in parentheses, 8.8 square root 5. Do you get it?
Still working on it. So the bottom one, it's the standard deviation minus the,
Not minus. Divided by.
like, for the bottom part. So like the top part on the equation, the top part is value minus mean, and the bottom part is what minus what.
It's standard deviation divided by.
So the bottom part is divided by 2.
Yes.
Okay. So it's what's the standard deviation? 8.8.
Yeah.
Divided
by the square root of 5.
which is like 2.36. 2.236.
That's not what I got.
What did you get for square
I
root?
got 0.467. So it would be 0.468.
For the square root of 5?
Oh. Well, no, I didn't put it in like that.
Oh, okay.
Okay. I just keep it in that way form.
Okay.
When I do my equation. So maybe that's it.
Okay, so wait, so it was standard deviation, which was 8.8, and then for me, I got the square root of 5, which was 2.236. So 8.8 divided by 2.236, which I got 3.936. 3.936, and then it's 9.2 divided by 3.936. And then I got 2.337.
Yeah.
And that is,
I got 2.337 as well.
okay. And that's the answer. They're just looking for the z-score.
Yes.
Oh. Okay, so I know how to do it.
2.338. Right?
It would still be 7 because after 7 I have another 3.
Really?
Yeah.
What the heck? I have a 7.
Maybe it's because we use different decimals, like we rounded differently. Well, okay, so you got 2.338.
Yeah.
I'll just go with that. Okay. So 10, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Okay, so we just put that standard deviation, that z-score
Yeah, I think
into
so.
the formula?
Yep.
And what was it above?
Yeah. So I got 0.0097.
Yeah, so 0.010.
It's 2 zeros. So it'd be point.
But we're rounding it. So it would be 0.010. Because the 7.
It says to round it, for this one, to round it to 4. So it would
Oh, okay.
be 0.0097.
Keep it where it's at.
Okay.
Wait to see that because I totally did not. Okay. So 11. Suppose the mean GPA of BYU Idaho's students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the standard deviation of a random variable which represents the mean of 81 students who are selected?
So would 81 be considered a high number?
Yeah, I think it'd be approximately normal.
Yeah, that's what I was thinking too.
Okay.
What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So how would we figure what is the mean of the distribution of the sample means? How would we figure this out?
Um,
Well,
um,
would it,
so
since it's a high,
mean of the distribution would it just be
would it just
no?
be the normal mean?
That's what I was thinking.
Because they don't give us we don't have any other numbers to work with.
And that's what I was thinking because you can't really find anything. So
Yeah,
I would just go with
3.5.
yeah, because I'm trying to go back in the homework and they kind of say that same question and it's
Mm-hmm.
just the normal mean I think.
Yeah, I don't see what else it could be.
Yeah, so I'd go with normal.
Okay.
Okay. So the next one is what is the standard deviation of the sampling distribution of the random variable, the mean of 81 students who are selected?
It would
So that would just be the
normal
regular.
0.7.
No, wait. No. I
No.
think that's the. Yeah, it's like the question that we had before. Hold on. Yeah, this is where we do that formula.
Okay, and what's the formula again?
Um, let me find it. So many things I just can't even remember anymore.
Is it under
um,
7 or 6?
I think we'd go back. I think we might even go back to 5. And 5 is where I found it last time. Oh, what the? Oh, I wasn't 5, dang it. Let me try 7. So I know it's not the same because the mean's the same, but the standard is not.
Would it?
So I think it might be standard deviation divided by.
Square root of
Yeah.
81?
Yep.
Okay, that's what I was about to say too. I got 0.77.
So 0. You mean
0.7.
0.77 or
Yeah,
0.077?
0.77.
Dang it! I got 0.077.
Okay, let me try it again. So it's so clear that's 0.7 divided by the square root of 81, which is 9. So 0.7 divided by 9. Oh, yeah, I must have put it in wrong because I got 0.077.
It would probably like you just put a 0 in front of the 7 or something
I
like
think
that.
I've done that, yeah. And it would
Let
have
me.
be rounded up to 0.078. 0.078.
Yeah.
Okay.
I'm just confirming our answer. By comparing it to another. Yes.
Okay.
That's what it is. I
Alright.
just redid a different equation and I got the same answer that they did. So,
Alright. 14. What is the probability that a mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
what's the probability? So we just find the z-score?
Z-score for 3.3?
Yes.
Using
So we would do 3.3 minus 3.5
divided by 0.078.
divided by
That is the standard deviation of the sampling distribution of 81.
7. Yeah. Divided by square root 81. Okay.
So for that z-score, I got 2.564.
I got 2.571.
Weird. Because wouldn't it just be because it's 3.3 minus 3.5 divided by 0.078?
I think because we rounded, it'll be slightly off. Because
Oh.
you're taking the rounded part.
And you did the non-rounded one?
Yeah.
So what should we use, rounded or not?
I would use not rounded.
Why do you say that?
Because if you just put in the formula like according to like the formula,
Mm-hmm.
like like the 0.7 divided by square root 81 or whatever it is. I don't know what it is, this one. Yeah, 81. Then you'd get that technically is the full equation, the full number instead of the rounded.
Okay, so what did you get for the z-score? Because they weren't that far off.
No, they weren't. It was just negative 2.571.
2.57. Okay.
So, and then
It's lower. So it's
Low.
left one.
Okay, hold on. So I got 0.0051.
I got 0. Wait, hold on. What was the z-score again?
I just accidentally logged out of that. Negative 2.571. So 2.571.
Okay, and then area was 0.0051.
That's what I got.
Okay.
If we're going below, right?
Yeah.
Yeah. Okay. So 0.0051.
But on
We're
this
doing
three
round
decimals.
to third decimal, so 0.005.
Yeah.
Okay.
All right, last one. We're almost there.
What is the probability that the mean GPA for 61 randomly selected BYU Idaho students will be greater than 3.3?
Oh, so it's just the same thing, only the right one.
Yeah.
And the middle one. Because the middle one. Yeah,
What's
it
the
would
answer?
include the middle too.
The middle one too?
I think, wouldn't it?
I don't think we've been using the middle one though.
But the problem is, for that one, it's because on 14, it was everything below 3.3. And then for 15, it would be everything above 3.3. So would it have to equal out to 100?
Wouldn't it? Would we just use the center one if it said 3.3 and above?
No, because the center, I'm trying to think. Because I don't know how to explain it, but I would think it would have to equal out to about 100 because if it's everything below and then everything above. No, hold on, let me read the question again.
I'll look at the notes.
I would think that it would include the middle because that is where the bulk of the people are. And that is because the average is 3.5, which includes I think it's the middle and the right.
Okay, hold on. I'm gonna try one of the formulas from the homework and see if that's what they do. Yeah, you're right.
Okay. I can see why it's confusing though.
So for ours, it would be 0.9949. Got?
Oh, hold on. I just had it up. Where'd it go? It would be 0.995.
Yeah.
Yeah, okay. Alright, do we want to go back through them again?
Yeah.
Okay. 3 is 0.175.
Okay, 4 is 0.055.
5 is the third one.
Yep. 6 is central limit theorem, third one.
7 is 1.045.
8 is 0.148.
9 is 2.338.
Question, hold on. Did 8 did we do the middle? Are we still doing the middle for the 8 on that one when we put it in?
Mm,
Because it is above. I just don't remember ever putting, like, the center one for me.
I think that one was different, I want to say.
Okay. Where does it go? Okay, I can see where it could be different.
Okay.
Because I guess, like, probably that a randomly selected student will get above that. I don't know. Keep it that way.
Yeah.
Okay, so mine is 2.338.
Yep. 10 is 0.0097.
11 is the third, approximately normal.
12 is 3.5.
13 is 0.078.
14 is 0.005.
And then 15 is 0.995.
Okay, let's submit it.
B, not bad.
Okay, yeah, 88%, I'll take that.
Yep. So it's just 5, 6,
Oh,
which
yeah.
is aren't even the ones that we'd used the
Yeah.
equation on, so.
Huh, okay. Well, alright.
Okay. Sounds good to me. I'll take it.
Yeah, I'm good with that. Alright,
And
well,
then, did you do you think you understand the homework now?
yeah, before I don't know what it was, but I just couldn't find the right equation to use for the samples. But now that I think I know, oh, it's standard deviation minus square root of, I think I got it now.
Okay. Yeah, and then like the first like couple ones, just it doesn't give you the numbers, so you have to go back into the formula without the number
Mm-hmm.
there. So I know that got me for a little bit because I skipped him for a while, but hopefully that will help.
Yeah, I think I definitely have a better understanding of it now.
Okay, good. Cool.
Alright.
So plan on same time again around.
Yeah.
Okay, cool.
Alright, and
Sounds
hopefully
good.
Karen will give me her phone number and then we can text, because texting will be easier.
Yeah, definitely. So we'll hopefully get that all established
Okay.
by next week. So sounds good.
Alright.
You have a good weekend.
You too.
Okay, see ya.